As opposed to tomorrow. Okay. I know. Okay, so we're going to work backwards today. Our goal with factoring is to turn it into a multiplication. So we were expanding, right? Getting rid of the brackets. Now we're going to go backwards, and this is called factoring because we want the factors. So think of it this way. If you had 20, the factors of 20 are what? Give me one factor of 20. 10 and 2. See, notice how you said 10 and 2. Why did you say 10 and 2? 10 times 2 equals 20. So notice it's a multiplication. You know it's a factor because you can turn it into a multiplication with another factor. And that's what we're going to do. We're going to take our expression and we're going to find its factor because it's going to multiply with another factor to give us our original expression. So we're going to learn how to actually pull out the common factor. So let's turn the page. This kind of first page is a write-off. And we already covered, remember doing GCF way back when? Yeah. So let's just review GCF here. And I'm not going to use prime factorization. Okay? Let's just determine the GCF here. So the easiest way to figure out the GCF is what's the largest number that can divide into 8 and 20? Well, what are the numbers that go into 8 and 20? What's one of them? 4. What's another one? 2. How about, will 8 go into 20?
Yes.
No. So the largest one is what? 4. Okay, so the GCF is 4. Now let's look at the variables. X squared and x. What's the largest variable that we can divide into both? Well, the trick here is actually take the smallest exponent. So we have x squared and x to the 1. So the largest that we could pull out of both of them, or what do they have in common? They have at least an x to the power of 1 in common. One has x squared and one has just an x. And so we actually take the smallest exponents, which is just x to the power of 1. Okay, why? Because our GCF has to be able to, we have to be able to divide both terms by each. Can I divide x squared by x? Yeah. Can I divide x by x? Yeah. So that's why I want the smallest one, because it has to be able to divide into both. Okay? Y squared and y cubed, then what's the GCF? Y squared would be the GCF. Y squared. Because can I divide both of those by y squared? Yes. Or another way to think of it is, can I pull out a y squared of both of those? Yes. Because that's basically what we're going to be doing. So let's try these ones. Let's write the GCF here. 12 and 15. Yeah, that was it. What's the largest number that can divide into 12 and 15? 3. Agreed. Okay, a squared and a. A. And then b and b cubed. B. Good. 18 and negative 24. 6. Yeah. 6. Okay, x to the 4 and x cubed. X cubed. And then y squared and y to the 5th. Y squared. Okay, so we look at both. There's y squared and y to the 5th, so we take the smaller one. Okay, so you take the smaller one since that's what you could pull out of both. Okay. The next one. What's the GCF for C? 1, right? 1 and 2 would just be 1. Do you have to write the 1? No? A cubed and A? A. Do they have a B in common? No. So no B's. How about C squared and C to the 7? C squared. And D. If they're all negative, you're going to factor the negative out. It's part of the GCF. So negative 40, negative 20, negative 10. Negative 10. We can divide into all of those. A cubed, A squared, A squared. A squared. Good. B, B cubed, and B squared. Just B. Wonderful. Because it has to divide into each term. So I can divide negative 10 into 40, 20, and the 10. Okay, so how do we actually pull out a GCF? So what we're going to do is our GCF, so if we look at 21x and 14y, what's the GCF for those? Well, 21 and 14, what can we divide both those by? 7. And is there a variable in common? No, so just 7. And so the GCF goes out front. And then how do we figure out what's left over? Well, we're going to actually divide each of them by the GCF to figure out what's left in the brackets. 21x divided by 7, 3x. 14y divided by 7, 2y. And so there it is. How could you check your answer? You can expand it. 7 times 3x, does that give you the 21x? Yeah? 7 times the 2y, does that give you the 14y? Yes. Okay. I hate when it's like brackets. So can we just do it ourselves? Can we go down to 5? And let's go through the process together. 20 and 6. It's the largest number we can divide into both of those. 4 won't go into 6. 3 won't go into 20. 2 it is. Good job. Okay, so I'm going to put the 2, the GCF, outside the brackets. Okay, now if we're pulling 2 out, we're pulling 2 out of each of those. So if we're pulling 2 out, we're really dividing each of them by the 2 to figure out what's left over inside the brackets. 10x minus 3. Okay, would you agree that those two are the same? Yeah, we just expand it and go backwards. It's the same. It's easy. Easy peasy. 16 and 4. 4. Okay. X to the 4 and x squared. Take the smaller power. X squared. Okay, hold on, folks. Okay, we're asking ourselves, what can we pull out of both? Okay, so looking at this, 16 and 4, the largest number I can divide both of those by is 4. Okay, so you have an x to the 4 and an x squared. Remember when we find the GCF, it's the lower power. So, because it's like what's in common. One of them has 4 x's and one of them has 2 x's. So they have at least, well, they have 2 x's in common. Because one has 4, one has 2, I could pull out 2 from both. Because that's what we're doing. We're pulling it out. We're factoring it out. So if one has 4 and one has 2, I can factor at least 2 out of both.
Okay, so we don't, for A, we don't do 2x because
there wasn't an x with a 6. So we couldn't factor out an x. Yeah. Okay, so to figure out what's inside of the brackets, really what we're doing is we're dividing each by the GCF. So what is 16x to the 4 divided by 4x squared? 4x squared. Okay, what is 4x squared divided by 4x squared? Just 1 plus 1. So anything divided by itself is 1. It's not 0. Okay, now how would you check your work? Expand it. 4x squared times 4x squared, is that 16x to the 4? 4x squared times 1, is that 4x squared? Yes. Okay, let's try another one. 10, 8, and 2. Little trick, take the smallest number and look at its factors. So the factors of 2 are just 2 and 1. So will 2 go into all of those? Yeah. Okay, 2, a cubed, a, and a. We could pull an a out of all 3 of those. Okay, b squared, b cubed, b4. B squared, we can pull b squared out of each. Okay, so when I take 10a cubed b squared and I divide it by 2ab squared, what's left over? 5 a squared. So a cubed divided by a is a squared. A b squared divided by b squared, 1. It's gone. Okay, so it might help you to write divided by 2ab squared divided by 2ab squared to figure out what's left over in the brackets. Should I make that bigger? Yep. Go big or go home, right? Okay, so 8 divided by 2. 4. A divided by A, what happens with that? Cancel. B cubed divided by B squared. B plus 2 over 2. Yeah, so cancels. A over A cancels. B4 divided by B squared. B squared. You with me? Okay, you ready to try D on your own? Okay, try D. Well, let's. You're done? Okay. Marcus. It wasn't very nice how you said that. Tone is everything. 12, 6, and 15. What's the largest number that goes into all three? 3. Okay, P cubed, P squared, and P. P. Okay, add your brackets. Now we divide each by 3p to figure out what's left goes in the brackets. Finish it off. P squared. Okay, so check. Did you get it right? Yay! You're so shocked. Okay. Let's do E. 25, 20, and 30. It's easy. 5. X squared, x to the 4. X, y squared, y 4, y squared. Y squared. And z to the 2. Okay. 25 divided by 5. It's 5. X divided by x. Gone. Y squared over y squared. Gone. Z cubed over z squared. Z. Minus. 20 divided by 5. 4. X squared divided by x. X. Y to the 4 divided by y squared. X squared. Z squared over z squared. God. Get out of town. Plus 30 over 5. 6. X to the 4 divided by x. X cubed. Y squared divided by y squared. Nope. Z to the 5 over z squared. Egg cubed. Looks worse than it is. Right? Okay. We have to do this one. Because it's going to come up in your homework. And if we don't do it, you're going to ask, how do I do it when you're doing your homework? Could be. Okay. Have you seen this formula before? Don't lie to me. Surface area of a cone. Okay. Let's go straight to number 2. Write A in factored form. So area equals pi r squared plus pi rs. What can we factor out of both of those terms? We have a pi in common. What else? Radius. R's only one radius. Okay, so if I factor pi r out of the first term, pi r squared divided by pi r is r. Just r. Because r squared divided by r gives you r. Pi rs divided by pi r is s. You know what's so funny is pirate jokes. I think they're funny. Like, where does a pirate go to relax? An R and R. Yeah. No, isn't it called? Yeah. What when they want to relax? I said it wrong. What, like, you know, rest and relaxation, R and R. Okay. I
Restaurant.
Arby's?
You would think that, but that's too long.
Long John Silver, so yeah. Okay. Okay. So turn to actually we need to go to lesson 2 now. So you feel comfortable with GCF, so let's take it to another level. Okay. Your greatest common factor can be a binomial. What? I'll say it again. Your GCF, your greatest common factor, could be a binomial. So let me show you what I mean. This first example, if I had 4x times y minus 3y, what would you factor out of both of those? I just made it up, okay? So what I did is I basically said x plus 7, I'm going to call y, okay? So instead of having a binomial, I'm going to have it as a y. What can you factor out of both of those terms? Y, okay? So I can factor y out and be left with 4x minus 3. Good. Okay? So ignoring this question here, if I just had 4x minus y minus 3y, I could factor y out of both. Agree? Okay? So in the same way, I can think of this as one term, and this guy is the other term. Okay? Where on my y, it's actually x plus 7. Y is x plus 7. So in each term, what's in common? X plus 7. So if they have it in common, we can factor it out. If I factor it out, I write my GCF, and then I write my brackets to figure out what's left over. Okay? So I'm going to actually move this down. So if x plus 7 is my GCF, I'm dividing each of these terms by x plus 7 to pull it out, to pull out my GCF. Okay? So what's left over when I factor out x plus 7 from the first term? Just the 4x. The x plus 7's cancel, and we're left with 4x minus the x plus 7's cancel, 3. So x plus 7 times 4x minus 3. Okay? So it's weird. I know it's weird. So let's try another one. It is a little confusing. The x plus 7's, because that was my GCF, so I divided each by x plus 7 to figure out what's left over. Yeah, it's in front of the brackets. Yeah. Yes, they both have to be identical to factor it out. Okay? So here, do they have something in common, these two? Yeah, they have what in common? 3 minus 2y. So if I factor out 3 minus 2y, we're going to pull out the 3 minus 2y's. What are we going to be left with? 7 plus 2y. It's actually pretty simple once you get used to it. Because you pull out the binomial, and once these are gone, you're just left with 7 plus 2y. That's all you have to do.
Okay, so basically you just have one of the greatest thing, and then that's at the front, and then whatever's left over.
Yes. Yeah. Like, think of it this way. If you had 7x, okay, plus 2y times x, right, where this 3 minus 2y is our x. I'm factoring out x, and I'm left with 7 plus 2y. But just what is x? X is 3 minus 2y. Okay, right? So instead of writing x 3 minus 2y, what if I wrote that just as x? Right? So if I factor that x out, I'm left with x times 7 plus 2y. Well, what was my x? It was 3 minus 2y. Kind of get it? Okay. So what can we factor out of this guy? What's in common? 4a plus 1. Well, here's a fun one. Okay, I pull out the 4a plus 1. What are we left with? 9a plus 1. Good. The coefficient in front, if you can't see it,
Wow.
is a 1. Mind blown. Okay. Ready to go again? Let's try the next one. 3y plus 2 we can factor out from each term. This is a tough one. Because what are we left with then? I need square brackets. 5y plus 1 plus 4y. Can we collect those like terms? Yes, so that equals 3y plus 2 times 9y plus 1. Okay, so let me use other brackets. Got it? Okay, so there was a 3y plus 2 in common. And like if you think of this as one term and this is one term. So we pull the 3y plus 2 out. Factor it out. When it's gone, we're left with 5y plus 1 plus the 4y. So we just collected like terms here instead. 5 plus 4, 9. Okay, because this is just addition inside, so we can add those. Okay, next one, what can you factor out? A minus 6, and we're left with 3a minus 9. Are we done? No. Good, 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 good. Oh, do you know why you said no? Oh, okay. You just thought he'd say no because I'm like, Miss Johnson's asking that. We're probably not done. Is there still a GCF somewhere?
Yes.
3. Greatest common factor. Okay, out of this term has a GCF of 3. Can you factor out 3 out of both of those? Yes, so we need to. 3a minus 9, can you divide those both by 3? So we need to pull that 3. So there's 3 now. Okay, so you have a minus 6 times 3 times what? I know, your mind's being blown. Okay, so I factored the a minus 6 out. We're all good with this step. Okay, so here, when we factor, we always want to pull out our, if there's a common factor, it must be factored out. Because that's how factoring works. You must always factor out. If there's a common factor, we must always pull it out. 3a minus 9 has a common factor of 3. So we're going to factor that 3 out. Divide each by 3. So put the 3 in front of the bracket, divide each by 3. We're left with a minus 3. Now this is not a proper way to write it, right? You wouldn't normally write a coefficient in the middle. So instead, what would make this look nicer? Put the 3 in front, and then write the other 2 factors. Because really, all these are just being multiplied by each other, all 3 of these. So it's better to write the 3 in front. Oh, does your head hurt? Okay. We're not done. Let's try C. Are these the same? No. Are they almost the same? Okay, so they're close. What's wrong? Opposite signs, negatives and positives of each other. Right. So could we pull out a negative out of one of them? Okay. So this is what I mean by that. Why not? Okay. If I factor out negative 1. Okay? So if I factor out negative 1 from inside here. So when we factor out a number, we put it in front. Well, 5 times negative 1 is negative 5. So when you factor out a number, we divide it, right? Yeah. No. No, because there's a number in front of them.
Oh,
So if you use distributive law, it wouldn't be the same thing and they wouldn't cancel.
just change
You change everything that's positive to negative and negative to positive. It's kind of like when you subtract, we changed it to addition by switching the signs. So we're going to change it to subtraction by switching the signs. Okay? So it's like instead, if I make the subtraction, I just switch my signs. Yeah. Okay, so I factored out a negative 1. So what I did by that is I divided each of those by negative 1. So why did I do that? Because I need my x to be positive, and I need my 5 to be the negative 1. So in order to just switch the signs, you're really dividing it by negative 1. So I have to actually factor it out so that these stay equal to each other. These have to stay equal to each other.
It's in the wrong order.
It doesn't matter, right? Are these the same thing now? Yeah, different order, but same thing. So think about it this way. When we subtract, we change it to addition by distributing the negative in. That's really what we're doing. We multiplied everything by negative 1. So we're going to do backwards. I want to pull the negative out. I want to change it to subtraction, and then backwards-wise, I have to switch the signs again. We're pulling the negative out. So if I pull negative out of 5, positive 5, we're left with negative 5. If I pull a negative out of negative x, we're left with positive x. We're pulling the negative out. And that's why this plus becomes a minus sign instead. Okay? All right, so I write this one more step. Would you agree that this is the same thing as 2x times x minus 5 times x minus 5? Okay? Yeah, you can use switch the order, absolutely. Now what do I do? X minus 5 it's factored out, and we're left with 2x minus 5. Okay, let's try another one. Same idea, right? But what's wrong? The 3 here is negative, the 3 here is positive. X here is positive, x here is negative. So we want to pull the negative out. So if we pull the negative out, yeah, you could do it to the 20. Yeah. Okay, so if I'm going to pull the negative out, what happens to minus 4? Plus 4 minus 3 plus x. Okay, so now could you write that instead as x minus 3 instead of negative 3 plus x? Yeah? And so now we can factor out the x minus 3. We're left with 20x plus 4. Are we done? Yes, there is a common factor in here of 4. Okay, we can divide both of those by 4. Where do we put that 4? Up front. Good. X minus 3 stays. So 20 divided by 4? 5x. And what's 4 divided by 4? 1. Thank you. It says of. Common factor of 4. I know that's hard to read. You know, you could theoretically go from here to here, and then here. Okay, one more thing. I know, we started off like, okay, I can handle this, and then it's like, well, yeah, I know. This is good practice for you over your break. I mean, what else are you going to do with your time, really? You don't have better things to do, right? Watch TV. Okay, factor by grouping. So factor by grouping, it's not common because you're going to learn another method later on, but you still need to know it. It's not a big step from what we just did. Okay, we have one extra step and then we're doing this type of stuff that we just did. So what is the extra step? The extra step is we group the first two and find a common factor, group the second two, and find a common factor. So x squared and 3x, what's a common factor? X. Factor that out, we're left with what? X plus 3. Okay, the second two, what can I factor out of both of those? 6, and we have to write plus 6. Okay, because there was addition there. If you factor 6 out of both, x plus 3. Do you know what to do from here? Got the same thing as before. So each of those, we're treating them as like one term. What's in common? X plus 3 is in common. I factor that out. Yeah, Cash got it. And we're left with x plus 6. Yay. Is it a big leap? Not really. So the first two, what can you factor out? A 2 and an x? Yeah, good. Okay. And you know with grouping, you should be left with the same thing inside the brackets. That's what we're working towards. Okay, 8x squared divided by 2x. 4x minus 2x divided by 2x. Thank you. Okay, negative 1. Yeah. 12x and minus 3. Just 3. We can divide both by 3. If there is no GCF, you write just 1. Thank you. I never get it anymore. I used to be so offended. When I was a young girl, I'd be like, oh, those dirty boys. Right? Now I'm like, please, guys, please. No one whistles anymore. Okay. 12x minus 3. What can we what divided by 3 is? 4x minus 1. Okay, good. Is that what we wanted to see? Yeah. We want the brackets, what's inside the brackets to be the same so that we can pull it out and put it in front. We do that and we're left with what inside the brackets? 2x plus 3. Look at all the learning you did today. C. I was going to make you do C on your own, but actually it's a little different. So we're going to do it together. C. What can we factor out about both of those? 4a. Okay. What are we left with? 2a. Nadir, you're getting this down? Yeah. Minus 1. Now we know we want to have what inside these brackets? The same thing. We want 2a minus 1. That's only possible if we factor what out? If I factor positive 5 out, would that give me 2a minus 1? No. That'd give me a negative 2a plus 1. So what would he actually factor out? Negative 5. If your first is negative, so that doesn't highlight. If your first term is negative, factor out a negative. Okay? So if the first is negative, factor out the negative. We have to factor out a negative 5. The reason why, if I divide negative 10 by negative 5, does that give me my positive 2? Yes. Yeah. Okay. And so one more step. 4a minus 5, or 2a, yeah, sorry. It doesn't matter actually the order. It's multiplication, but really what we're doing is factoring 2a minus 1 out. We're left with 4a minus 5. It's a long lesson. Sorry, guys. Do you want to try the next one? Okay. Sometimes it happens where if it doesn't work on the first try, you're going to have to rearrange it and try a different combo of pairs. This one would work You factor 3a out. You're left with 2a minus 3. Factor negative. Did you try it? Give this one a try. You try. Yes, you do. You lie. Did anyone try F yet? If we tried F together, right, let's do F. E is easy. Unless you want to try it on your own, or are you good? Okay, let's just do E. What's in common out of the first two? P, and you're left with Q plus R. Okay, what's in common out of both of those? Not just S, negative S. Okay, if the first is negative, factor out the negative. So negative SQ divided by negative S, Q, negative SR divided by negative S, plus R. And so we factor out the Q plus R, and we're left with P minus S. Yep. Oh, we did, actually. We took out negative S. So we took out the S and the negative, because the first was negative, but they're both negative, so we wanted to pull it out. So we kind of did. But there was also an S we could pull out, so it became negative S. Right. So it's like a negative 1S. All right, the last one. Is there anything in common in the first two pair? No, it'd just be 1. Okay, so don't write this down, just watch, okay? In the second two, is there anything in common? Minus 3 and x, which gives me 5y squared plus 2. Okay, are those the same? No, so sometimes in grouping, when you do that, when you group, it doesn't work. So you have to rearrange it, rearrange the groups or the pairs. So instead, let's try 5x squared minus 15xy squared, and then write the plus 18y squared minus 6x. We're going to rearrange it. Okay? So just rearrange it in a different order. So if it doesn't work the first time, try rearranging it. So I'm just going to change the order of the polynomial. Okay, now the first two. What can we factor out? 5 and x. And what are we left with? X minus 3 and y squared. Okay, plus, what can we is there anything in common in the second two? 6, and we're left with 3y squared minus x. Are those close? What's the difference? You need to flip one around. Even if I flip it around, so if I rewrote this guy, the second guy, I could write it instead as a negative x plus 3y squared. Is it the same? No, what's wrong? You need to factor out a negative 1. Let's do the second one. So we're going to pull out the negative. So the plus 6 becomes negative 6. The plus minus x becomes plus x. The plus 3y squared minus 3y squared. Good. Now we can finally pull out minus x minus 3y squared, and we're left with 5x minus 6. I don't know if you have room for that. Sorry. The long one. I believe. Let's turn the page. Oh yeah, AP stuff. Oh. How are we doing for time? When do we have till? 1:45. Here's the thing, if we don't do it now, yeah? Tomorrow, yeah. Okay, who's coming in tomorrow during lunch?
I'll come in.
Yeah. Exactly. Okay, I'll give you. Ha! Ha! All right, we're starting. Okay, in each case, a common factor has been removed so that the remaining factor is an integral binomial. Complete the factoring and check mentally by expanding the factored form. So when we have a fraction, we want to factor the fraction out. Okay? I find the easiest way to do this, you put your phones away and stuff, guys, is to get a common denominator. Okay? So, if you have 1/3 x plus 4x, if I want to get a common denominator, what's the fraction with 4? It's 4 over 1. So, to get a common denominator, I would want it to be over what? 3. I would want it over 3. Okay, so this would be plus 12 over 3x. Okay? So would you agree that 4 over 1 is the same thing as 12 over 3? Okay. 12 over 3 is that not the same thing as 4 over 1? So, 1/3 and 4, they're not, 4 is the same thing as 4 over 1. So I want a common denominator. How I do that is I multiply the numerator and the denominator by 3. Why? Because I want a common denominator. We're going to factor out the fraction, and so the easiest way to do that is actually get a common denominator. Okay? Because me telling you to take 4 and divide it by 1/3, most likely you're not going to go instantly 12. Some of you might be able to do that in your head. Some of you may not be able to. So I'm going to show you using a common denominator. Yes?
So where do you multiply 3 by the x value?
No, just the coefficient. Right? Because when we're multiplying, we only multiply 2 things at a time. You wouldn't use distributive law because there's no plus there. Okay? So this becomes 12. 12 over 3 is the same thing as 4 over 1. Exact same thing. Equivalent, right? 12 over 3, 4 over 1. Aren't those the same? Okay, I don't know how many ways I could say that. I clearly would not make a great elementary teacher. Okay, so what we're going to do is we're going to pull out our common factor. So looking at the numerators, 1 and 12. Looking at the numerators of 1 and 12, the only thing I can factor out is 1. Looking at the denominator, 3 and 3, I can factor out a denominator of 3. Okay? So I looked at my numerators. Oh, well, actually, let's go back to this part. I look at my numerators. I look at my denominators. So on my numerator, I could factor out a 1. My denominator, I can factor out a 3. And then x squared and x, I can factor out a x. So what's left over? 1 divided by 1 is just 1. 3 divided by 3 is just 1. So the 1/3 is gone. X squared divided by x, plus 12 divided by 1 is still 12. What happens with the 3? Just 1. It's gone. If I factor 3 out of 3, it's 1. So we're just left with the 12. Okay, that's it. Okay? Because if you look at the numerator, I took out a 1 out of the numerator. Well, 12 divided by 1, 12. Then the 3, I factored out 3 out of the 3. 3 divided by 3 is 1. So you could write that as 12 over 1, which is just 12. Okay, let's try another one. So before I go to the last step, a quarter a squared minus, how do I write 4, or 4 over 1, instead with the denominator of 4? 16 over 4. Good. So we're factoring out, if you look at the numerators, they have 1 in common. If you look at the denominator, they had 4. Agreed? And then a squared and a, we can factor out an a. So what's left over when I factor out 1/4? A. Another way you can think of this is we're dividing each of them by a quarter a. A quarter divided by a quarter is just 1. A squared divided by a is just a. A minus what? 16. You pulled out the quarter from the denominator. Yes. Okay. So let's try the next one. Common denominator would be 3. Good. So in order to make this 6 over 1 instead over 3, it becomes 18 over 3. Agreed? X plus 2/3. So on the numerator, if I just look at the numerators, what can we factor out? 18 and 2. 2. Good. We factored a 2 out of the numerator. Good. And then we could factor the 3 out of the denominator. And is there an x in common? No, just the 2/3. So when I factor that out, I'm left with, okay, so 18 divided by 2, 9, x. The denominator is always gone because we're always factoring out the denominator. That's why we got a common denominator, so we can get rid of it. So always I'm factoring out the 3, and so it's gone. Plus 1. Hey. Okay, 2/3. We had 2/3. We factored 2/3 out, right? So if you look at the numerator, 2 divided by 2 was 1. 3 divided by 3 is 1. So here, I factored a 2 out of the numerator. So when I factored the 2 out of the numerator, I'm just left with 1. Factoring 3 out of the denominator, I'm left with 1 over 1, which is 1. Okay. Okay, common denominator of the first. Is it a common denominator? No, we have to change this to 2 over 4a squared minus 3 over 4b squared. So looking at the numerator, do you see how they got the 1? 2 and 3, is there a common factor? No, so just 1. And then can we factor the 4 out of the denominator? Yes, because they each have a 4 on the denominator. So when we factor out the 1/4, what are we left with? A 2a squared minus 3b squared. Right? We're pulling out the denominator. That's why it's because it has the 4 on the denominator. It's gone. And then we just factored 1 out of the numerators. So that's why we have 2a squared minus 3b squared. Yeah. This is AP, so this could be on your AP quiz.
But it's not on the exam.
Not the unit exam, no. Okay? Okay, next one. Common denominator. What's the coefficient of the first variable? 1, so we could write that instead as 6 over 6. A minus 1 over 6a squared. So what are we factoring out? 1, 6, and a. So would you agree when you factor out 1, 6a, we're left with 6 minus a? Yeah. Good. Let's do it ourselves. I hate to fill in the blank. Let's go down to this last question, then we're done. So how do I make this a common denominator? So this is 2 over 1, so we're going to make it instead as 8 over 4a plus 1 over 4a cubed. What can we factor out of the numerator? 8 and 1, so just 1, and then over 4. We're always taking out the denominator, always. And an a is in common. Good. So 8 divided by 1, 8. 4 divided by 4 is gone. 8a divided by a, it's gone. Plus 1 divided by 1 is gone. 4 divided by 4 is gone. A squared. Done. Okay, try B on your own. And we'll the last example. Where'd it go? There it is. We factor out 16x, and you're left with 6x squared plus 2x minus 1. Okay, there's your answer.
I win.